So today we're doing an integrated rate problem, integrated rate law problem. The question asks, the rate law for the particular reaction was found to be rate equals K times A to the second power. If the rate constant was found to be 0.155 molarity times second, and the reaction started with an initial concentration of A equaling to 0.0170 molarity, how long would it take for the constant concentration of A to reach 6.25 times 10 negative 3 to the times 3 molarity? So based off this problem, you can tell that this is a second rate law equation. So this second law equation is 1 divided by the concentration that we're trying to find the time for, which is this, equaling to the rate constant times time, which we'll be looking for, plus the initial concentration fraction, which is 1 over this. So in order to find the time, all you have to do is just plug in these numbers into the equation. So let me erase this for you. So 1 divided by 6.25 times 10 to the negative third power molarity equaling to the rate constant times time, which is 1.55 times time plus the initial concentration fraction, which is 170 molarity. Alright, so the first thing first, in order to find time, you want to isolate everything onto the other side of the equal sign. So the first thing we're going to do is subtract this on both sides. That's much better. All right. Minus the initial equation, initial concentration fraction. Equaling the rate constant times time. All right. So, there's many ways you could go about this next step. If you want to be lazy, you could put it in a calculator, or if you want to do it the hard way, you can cross multiply this in order to solve this next step. So, we're going to do it the hard way today. So, all we're going to do is just cross multiply this fraction, and we're going to sum it up a little bit. So, 1.70 minus remember, you're cross multiplying, so both of these denominators are getting multiplied at the bottom. Running out of space, I'm gonna have to bend down. And then once you just type this in the calculator, I doubt you'll do this in your head. We'll write down the answers. So maybe divide. Make sure when you do this, you type this in the calculator properly, because it will mess up your answer if you don't. And remember, these are getting multiplied, so the molarity is getting squared. Equaling this comes down the same still. Alright, so before you do anything, if you look at this, you can close this down a little bit because both of these are molarity, but this is squared. And since it's a division problem, you can cancel out one of these m's and that would become that. But this meaning, since this is on the bottom, if you bring this up, it will be molarity to the -1. Or you can leave it at the bottom, either or. I'm gonna show you. So after you divide this, you should get an answer like this. Now you can either write it like the molarity being this, or it'd be much easier if you just leave the molarity at the bottom like this. And then this still comes down. We ain't touched the right side yet. Now, you might erase most of this. Need more space. I'm gonna bring this back to the top, matter of fact. We on? Alright, so we're almost done. So next thing is we're gonna cross multiply. This need to be equal sign. We need to cross multiply because we want to get t by itself, but we want to isolate as much as possible. So we want to cross multiply. So this will stay the same because it's getting multiplied by 1. But this molarity variable is coming over here. Or you can write the m separate if you want to, but it's still going to add up to each other, so it just makes sense. So the next thing is, all we're going to do is just divide this to get t by itself. Once you do that, this will cancel out, this will cancel out, this will cancel out, that will cancel out. Now, once you divide this, remember this is on the bottom as a negative, so if you're bringing this up, it will become seconds, which you're looking for, and the answer will be, if you just type this into the calculator, you should get 6.5237 seconds. Or you can just round it up to be 6:53 seconds. And that's it.